Kids? All right. I am going to introduce something that's related to dynamic fluids, so moving fluids. This is the first basic thing. It's called the equation of continuity, but it's essentially this, and you probably already know about it. So let's say here you are. You're having a nice day, la la la. You drag the hose out, and you're like, hey, I want to water this giant flower in my yard, because you got to make sure your giant flower stays alive. And you pull the hose, and this is as far as the hose goes, and you turn the water on full blast, and the water only goes to there. And then you're like, boo-hoo, because I can't water my giant plant that's in my yard. So what do? Well, here's what you do. You take and you cover up the end of the hose with your thumb. So where the hose at the end, if you look at a cross section, it goes from having an area like this to having an area like this, because you covered up that part with your thumb. And all of a sudden, when you do that, so when you put your finger on the end of the hose, so here's his finger at the end of the hose, well, you already know the water comes out much faster, and it makes it there. And you probably never even thought about, well, I don't know why that happens, but this is why that happens. It's called the equation of continuity. Essentially, it's saying this, okay? Whatever water goes through the hose here has to come out there. So the volume here has to be the same as the volume there. It's just the volume flow rate, the volume flow rate must stay the same. Why? Because if it didn't stay the same, like how can you have more water here than you do there? You can't. Whatever water is there has to come out there, unless there's some weird leak in your hose. So this is really saying the volume at spot 1 per time has to be equal to the volume per time at spot 2. So if I call this spot 1 and I called this spot 2, that's what it is saying. Another way of saying this, if you wanted to do this a slightly different way, if I wanted to show this to you, because essentially what we're doing is we're making the hose have a smaller area. So let me show it to you this way. So let's pretend here is spot 1 and over here is spot 2. Does everybody see that okay? Well, how do I figure out the volume? If this is a hose, it's cylindrical, so that would mean I need to have a cross-sectional part of the water, and let's say that is the volume of my water at part 1. You can kind of see that. I know I'm an amazing artist. I did minor in art, and that's my 3D piece of water flowing along. Well, over here, if this is my volume, remember this, how did we find this volume? We had a big area times a small distance this way, okay? Or if you want length, whatever. Where over here, if I want that same volume, well, how do I make that same volume? Well, over here, I'm going to have a much smaller area, but I'm going to have a much bigger distance. So over here, it's a much smaller area, and I'm going to have a much bigger distance. Hopefully that makes sense. Well, if we plug that in so that I was to have A1 times D1 over T equals A2 times D2 over T. Again, all this is saying the volume flow rate has to equal the volume flow rate. Well, if you look right there and right there, I have D over T. D over T is little v, not big V. Big V is volume. Little v is going to be your speed. So then you're going to end up with A1 times V1 equals A2 times V2. And that is called the equation of continuity. Why is it called that? Because it is called that because, hey, whatever volume comes in has to be the same as the volume coming out. Now, here's where you have to be careful, even though this is the equation you're going to see on the equation sheet. Every so often, the College Board is going to throw a question like this at you, where they will say, hey, you know what? I have these two branches coming together like this. Well, in this case, you would have to say, all right, well, this would be like 0.1, this would be 0.2, and then this would be 0.3 maybe. Well, you just draw your picture and you make sense out of this. So in this case, it's not A1 equals A2. Why? Because the water, we'll say the water is flowing this way. It would have to be like this. It would have to be, hey, A1 V1 plus A2 V2 equals A3 times V3. Duh. Okay, so it's just saying, again, the volume here and here has to be equal to the volume there. There you got it. So equation of continuity. We're not memorizers. We're going to understand. Bye, kids.